Alright, this is for number 2, parts A, B, and C of the mid-module assessment. Number 2 starts off, model the number 8 and 88 hundredths on the place value chart. Either one of these would be acceptable. The decimal is here. You could have written in the digit 8 in the ones place, an 8 in the tenths place, and an 8 in the hundredths place. It also would have been acceptable to use place value discs and count 1, 2, 3, 4, 5, 6, 7, 8 ones, 8 tenths, and 8 hundredths. Either one of those models is acceptable. Then, when you scroll down to part A, it says you need to use words, numbers, and your model to explain each of those digits and why they have a different place value. We made sure to put a box around that in your assessment so you would remember to do all three. Well, your model is already here if you drew in the place value chart. Remember, it wasn't given on the assessment. You actually had to make your own chart. So I'm going to cross off the model because I already have that here. When you use your words and numbers to explain, you need to talk about how, yes, each one of these digits is an 8, and an 8 has the same value, but they're in a different place value spot. 8 ones is not the same as 8 tenths, and that is not the same as 8 hundredths. And when you explain that, the direction said use 10 times as large in your answer. Well, an 8 in the ones place is 10 times as large as an 8 in the tenths place. And to use 1/10 as large, you could say 8 tenths is 1/10 as large as 8 ones, or you could say 8 hundredths is 1/10 as large as 8 tenths. Here's an example of what you could have written on your assessment to get this correct. Here they show you the place value discs. They modeled 8.88 or 8 and 88 hundredths and said an 8 in the ones place is really 8 times 1. So they're using their words to explain why each of the digits has a different value. An 8 in the tenths place is really 8 times 1/10. And an 8 in the hundredths place is really 8 times 1/100th. And here again they explain the 10 times as large or the 1/10 as large. You needed to have all of those things to get full credit on this problem. Moving on to letter B, they asked us to do a multiplication problem. It was 8 and 88 hundredths times 10 to the 4th power. So that looks like 8.88 times 10 to the 4th power. Now when you multiply by an exponent, that 4 is really telling you how many place value spots. That's a 1 with 4 zeros after it. Well, a 1 with 4 zeros is 10,000, so that number is going to get 10,000 times bigger. To model that, I'm going to write 8.88, and I'm going to move that decimal 4 place value spots to the right, so it is going to get 10,000 times bigger. There's 1, 2, 3, 4. Now you'll notice I have 2 blank spaces there. That means I need to put in 2 zeros. And the new decimal point goes here. Well, that's like an invisible decimal because I don't have any digits in the tenths place. So this is a whole number. And if I count over, the comma would go right there, and that number would be 88,800. You can see it's modeled here. There's my equation, 8 and 88 hundredths times 10 to the 4th power. They moved it over in the place value chart to get 10,000 times bigger. And in their explanation, you'll notice they said each digit does shift 4 places to the left. 10 to the 4th is a 10 times 10 times 10 times 10, which is also 10,000. So each digit becomes 10,000 times as large, or 10,000 times bigger. That is what you need to explain the shift of the digits. Moving 4 places to the left is the shift of the digits. And why the value of each digit changes, because it's getting 10,000 times bigger. What was tricky about letter C is that they asked you to divide the product from B. You needed to remember that the product is the answer to a multiplication problem. In letter B, when we multiplied 8 and 88 hundredths times 10 to the 4th, we got 88,800. So when we start C and we have to divide that product, I need to bring that all the way down here to start letter C. So I'm right away starting with 88,800. And I'm dividing this time, which means my answer is going to get smaller. And I'm dividing by 10 to the 2nd power. So you can see it modeled here, 88,800 divided by 10 to the 2nd power. And here's how they show you the shift of the decimal. They put it in the place value chart. It's getting 100 times smaller because 10 to the 2nd power has that exponent of 2. So they slid it over 2 place value spots in each digit, and they got 888, which is 888. When you talk about explaining the shift of the digits, here it is. Each digit shifts 2 places to the right. And why does the value of each digit change? Because 10 to the 2nd power equals 10 times 10, or 100. So each digit becomes 100 times as large. I would also accept 100 times smaller.